All right, so day 6, negative exponents and how they relate to the reciprocal. So let's take a look at the pattern that they're offering us on this note page. Look at this pattern. What are they doing here? What's going down by 1? The power or the index, right? 3 to 2 to 1. And then how does that relate? How do you go from 1,000 to 10 to 100? Divide by 10. Or in other words, you're just removing a factor. Like this one is 10 times 10 times 10, correct? And what's the 100? 10 times 10. So you're removing a factor. What's this one? 10. So how do you remove a factor one more time? 10 divided by 10 is 1. I'm going to put a big blue box around this one. What did the video say yesterday? Anything to the power 0 is beautiful. Now, if you continue on with this pattern, like take a look at the pattern on the left, 3, and then 2, and then 1, and then 0. The next one on the list is -1, and then -2, and then -3. So you continually divide. So if I divide by 10 one more time, I get 1/10. If I divide by 10 one more time, I get 1/100th, which is the same as 1 divided by 10 squared. Divide by 10 one more time, you get 1 over 1,000, which is 1 over 10 cubed. Now all you have to do is look at the symmetry. Look at 10 to the -3 and compare it to 10 cubed. It's the exact same thing except in the bottom. It's the exact same thing except in the bottom. So let's try this on the whiteboard. 5 squared is 25. You guys are good with that one? So then what would, these can be related, what would 5 to the minus power 2 be? 1 over 25, which is just 1 over 5 squared. So look what a negative power does. It just flips it. It flips it, just like when your parents tell you to do your homework. You flip out. You say, listen, Linda. You guys ever see that video? Oh my gosh. Now every day at home, my wife tells me to do something. I'm like, listen, Linda. Okay, here we go. Let's do this pattern. 3 cubed, 27. 3 squared, 9. 3 to the 1, 3. 3 to the 0, 1. 3 to the -1, 1/3. Don't go to the decimal. Don't go to the decimal because you won't see the relationship. What's this one? 1/9. What's this one? 1/27. Which would be the same as 1 over 3 to the 1. 1 over 3 squared. 1 over 3 cubed. What do you guys think about that? So this is all new stuff. We didn't do this yesterday. This is all new stuff. Okay, let's take a look at 5 to the 4 divided by 5 to the 7. So my exponent law rule says I have to take the first power and subtract the second power. And 4 take away 7 is -3. That's what my rule says. That's my rule. But do I understand what it means? Do I understand what it means? Think about this as a fight. Who's going to win that fight? 5 to the 7 or 5 to the 4? Who's tougher? And by how much? So you leave 3 in the bottom. I wonder if you could write it out. If you had enough room. 5, 5, 5, 5, 5. Something's wrong with the random number generator. 5, 5. That was a joke, by the way. The 5s cancel, you agree? How many are left over? In the bottom. So this equals 1 over 5 cubed, like that. That was from a Dilbert cartoon. You guys know Dilbert? He's like 9, 9, 9, 9 over and over again, and he's like, something wrong with the random number generator. That's a funny joke. It's so funny I had to repeat it. All right, so the general expression, let me just back up one step right here. The general understanding of these negative powers is that you just have to flip it and then change the sign. So the better word for flip is reciprocate, and change sign of power. Just remember, a lot of students will do this. They'll change the sign on the base. Don't do that. Do not change the sign of the base. It's just the sign of the power. So especially those that forget to study, they'll start changing the signs on the bases, and it'll be weird. So I'll put a little star down here. Don't mess with the base. The sign stays the same for the base. So the first one, all I have to do is take this -1 to a +1. You guys will feel okay about that? Okay, now check it out. You actually have a negative power button right there. So hit 2 power -1. What do you get? It's right here. X to the -1. So if you hit 2 and then that button that says X to the -1 and you hit enter, you get 0.5. On the calculator, it looks like this. Like this. Now, like for the next one, though, you can't use that button. You can't use the button. For the next one, because it's a 2, right? So for the next one, like, go 3 and then the power button, -2. What do you get? 0.11111? So I wonder why that is. Let's check this out. You want to rewrite this with a positive power, and then 3 squared is 9. If you check 1 divided by 9 in your calculator, it'll be the same. 1 divided by 9 is the same as 3 to the power -2. You guys will feel okay about that? Right then. The next one will be just 1 over what? 1 over 4 what? Good. 1 over 4 cubed. Good. Which is the same as 1 over 64. All right, on this next page, we have some summary. This will be 1 over a to the n. And the reason that is because what this base actually is a over 1. Think about that. If any integer, like a, there's a little divide by 1 that you don't have to write. So then when you flip it, you get a 1 on the top and a on the bottom. So what would this one be? Next one. it would be b over 1 to the n. Okay, which is just, it's just b to the n, right? And the last one, I'll flip it, and then I get, so that's probably the most important one, this third one, because it generalizes all of it. No matter what you have for a fraction, if you flip it, you just have to switch the sign on the power. Notice nothing happens to the base in terms of sign. Like, only negative switching will happen in the power. Now we have all this beautiful stuff. Like, this stuff is beautiful. So this is 4 to the power negative 1/2. I don't want to deal with the negative power, so it's going to be, whoops, it's going to be, I'll do it underneath, 1 over 4 to the positive 1/2. One of the exponent laws says that if you have a division with a power, the power has to go on both. So you have 1 to the 1/2 over 4 to the 1/2. See how you have to put it on both? What's 1 to the power anything? 1. And then what's this last one? Square root of 4 is 2. That's what we did. Square root 4 to get 2. Because the index, the denominator, the 2, it tells you it's a square root. Next. 9/16 power negative 1/2. Like, excuse me, negative power, I don't like you. Go away. How do you make a negative power go away? Flip it. What's the 1/2 power again? 1/2 power is what? This one you should just memorize. 1/2 power, square root. So I got square root 16 on top of square root 9, 4 over 3. Guys okay with that? Now this one looks like it came from the quiz. This next one. How do I get rid of the negative power? Flip it. This one's really important because there's a lot of crap going on. Do you see how the negatives just stayed in the base? You see that? I didn't mess with that at all. Only the thing that switched was the negative power to the positive power. See how it switched? In order to switch that, I have to flip the base. So that's the only thing that's happened. I've flipped the base, switches the sign on the power. Now remember on the quiz today? The very last step in the quiz, you had a negative divided by a negative. You remember that? And it came out to be a positive. So when is your fraction negative? They have to be different, right? The top is negative and the bottom is positive, or vice versa. They just have to have alternate signs. So is the 27 negative or is the 8 negative? Does it matter? It doesn't matter as long as one of them is positive and the other isn't. Does that make sense? They have to have alternate sign. Okay? So just pick one. I'm going to choose that the negative 27 be negative. The 27 will be negative. Then that means the 8 has to be positive. If I chose the 8 to be negative, then what would the 27 be? Good. They have to have alternate signs. And then what's the third power, the 1/3 power? Not a square root, but what would a 1/4 power be? Fourth root. What would a 1/5 power be? Fifth root. Good. Cube root of 27? -3. Cube root of 8? Now look at this result. You have a negative divided by a positive. What's a negative divided by a positive? The whole fraction is negative, so you can like scoot it off to the side. It doesn't have to be on one or the other. The whole fraction is negative. Letter D is too easy. You guys agree? Hit this in your calculator. Hit this. 4x to the -1. Should get a quarter, right? 0.25, quarter. Next one is also very easy. Why? Just flip it, and then what's anything to the power 1? Itself. So doing this kind of stuff, it's like redundant. You know it's going to be true. Sorry? Oh yeah, I'm just a copy paster, you know? Don't care. My OCD usually kicks in on stuff like that, but then I weigh like the time it takes to fix that versus like, does it really matter? And then also like, sometimes Microsoft Word is just so annoying to work with. Anyways, let's take a look at this one. All right, first things first. What is the reciprocal of 8? Good, because 8 over 1 would become 1 over 8. So we can go like this. If you flip the base, you have to change the power in terms of its sign. Now, what's the top going to be? 1 to the 2/3? And what's the bottom going to be? 8 to the 2/3. What's 1 to the power of anything? It's just the bottom that I got to think about. Oh my gosh. Oh my gosh. Fraction power. Do I give up or do I just think? What does the 3 tell me? Cube root. What does the 2 mean? Square. So what's the cube root of 8? Then square that. 4. So I would do it in this order. Do that first, then square it. I get 1 over 2 squared. I get a quarter. You can't see that? Oh my gosh. I used to have a teacher, I sit in the back of the room and he'd be rolling on the projector, rolling on the projector. There's no zooming in. You didn't see it, you didn't learn it. Sure, check that out. Mad technology. Okay, how about this guy? Oh my gosh. We already talked about that. Okay. I'm going to switch this to 4/3. So what can I do? How does that change this negative 3 up here? Becomes a positive 3. Good. And what do you notice? What did that do to the negative on the base? Nothing. Every year, though, I have students do that. They make up their own rules for the exponent laws. It's kind of funny when you mark it. Every year, someone will make that mistake. They'll flip it, and then they'll switch the sign on the base. So don't do that. Don't be that person. So I got 4 cubed over negative 3 cubed. Is that okay? Is that okay? Yeah, because it doesn't matter. As long as one of them is positive and the other one isn't. What's 4 cubed? Good. And what's 3 cubed? 27? What's a positive divided by a negative? A negative. I don't think 64 and 27 have any common factors, do they? I don't think so. Because the whole fraction is negative? So like the 3 is positive and the 4 is negative, or vice versa? The 3 is negative and the 4 is positive. As long as one of them is negative and the other one's positive. Because a positive times a negative is a negative. Yeah. 64 27th is in lowest term, so we don't have to do anything with that. Okay, now this one is just going to crush. This one's tough. Why is this one tough? What? Decimal, good. What position is the 3 in? The 10th, right? Let's just back it up a second. This is just an aside. Look at this number. This is just, you don't have to write anything, just think about this. Where's the 3? In the tens, right? So what that means is you have 3 in the tens position, and 3 times 10 is 30, right? So what does this 3 tell us? It's in which position? So you have 3 tenths. That's the fraction. 3 tenths to the negative 4. What can I do with the 3 tenths? Reciprocate it. Now the whole fraction is being raised to the power 4, so each one gets raised to the power 4. And I evaluate them separately, and I think this is 81. 10, 10, 10 is 1,000. Oh boy, 10,000. That looks better. I think that's good. What do you guys think? Any questions about that one? That one's good. Going once, going twice. Oh, look at this guy. Did you still need that slide? Oh. Just use your regular voice. All you have to do is ask. Bum, bum, bum. Yeah. Very nice. And if it was like 0.37, it'd be 37 out of 100. Like this. Well, what do you guys think? So later, guys, when we start to merge all of these rules into like one massive question, My preference is to deal with the negative power first. I love to just get that out of the way because all it takes is a flip. And then I don't have to deal with negative power. So I'd love to just take care of the flip first. I always do that, personally. You don't have to. Like, you could take the square root and flip it after, but I like to flip first. So then, what does this little 2 tell us? So we have square root, because you have to do it to both. Why do you have to do it to both? Because the power is on the entire bracket, right? The entire bracket has this power. So I got the square root of 16 and the square root of 9. And then once I do that, what do I have to do next? Yeah, put the power 3 in there. So I like to take that radical first because it makes it smaller, usually. Square root of 16 is 4. Square root of 9 is 3. And I still have to cube those, do them separately. 64 over 27. I feel like we did this one already. The exact same one? No, it's just different power, right? But I feel like we got 64 over 20. Oh, it's over there. So I guess you start to see the patterns in the numbers. You're going to see those perfect squares, perfect cubes that are on your list. All right, let's keep rolling. Oh my gosh. Look at these. So this page, clearly they're challenging, obviously, right? Clearly they're challenging, right? You're going to have to really spot the patterns and look for similarities. Like, let's look at this first one. They both have what? They're both 2/5, right? So if you guys could do this one earlier, x2 and x3 makes x5, then you can do this one. What would it be? 2/5, and then what goes in that power? Because this is a times, right? What do you got to do to these two powers? Add them. Very nice. -3 plus 2. All that's going to be in the power. And outside of that, I still have this -3. Do you agree? So I'm like working my way from the inside out. Because that's the order of operations for brackets. Work inside out. Okay, how does that simplify? -3 plus 2 is? -1. And I still have a -3 out there. Now I have options. Do you guys remember the power of a power rule? What's the power of a power? Not when you add them, but when you... Yeah, good. Like, what's x squared cubed? X to the 6, because you multiply them, right? So could you just multiply those? What's -1 times -3? 3. So you have 2/5 cubed. 2 cubed over 5 cubed. 8 over 125. So I multiplied those powers. The -1 and the -3, I multiplied to get +3. Did I have to do that? I could have worked my way from the inside out. Like, what's 2/5 to the -1? That would be 5/2. And then 5/2 to this. I'd have to flip it again, back to 2/5, and then cube it. Works out. Let's go to the next one. All right. This one as well, you have options, but I love to just do what first? I like to just flip out. Okay. I think that's the easiest thing in the world, so I love to just get that out of the way. Because all you have to do is copy it down and switch the power. Now again, you still have options, like you could apply this power 2 to everything, but like I don't want to do that. I got some experience. I understand that. I think this would be easier just to simplify this first. So I'm going to highlight this guy. That's really pretty. What's 6 divided by 24? First of all, I bet you could do it if it was reversed. What if it was 24 divided by 6? What's 24 divided by 6? But that's not what they're asking, is it? It's 6 over 24, so it's 1 over. It is 0.25, but we want to keep it as a fraction. 1/4. Right? Now I'll just show you the biggest shortcut in high school math history. And if you hate fractions, you need to be doing this. 6 divides 24 in that order. Enter, math, enter. Okay? Like if your number sense for fractions just isn't quite there, you need to be using this. Okay, so 6 divides 24, that's right from the question. That's the coefficient. And then just hit math, enter, enter. Okay? Okay? Now let's take a look at the x's. How many on top? How many on the bottom? Who wins that fight? By how much? So you have x to the 1 left over in the top or the bottom? Top. And I guess I could put a little placeholder there if you like. You don't have to have that placeholder. Now let's take a look at the y's. Now the analogy between the fight, this really screws it up now because you got negatives in there. This one, I'm just thinking to myself, wow. I might just want to memorize a rule for this one. What's the rule? When you divide same base, you don't add them, you subtract them. So this one's a little bit different, so I'm just going to follow the rule because it's scaring me. Sometimes just following rules blindly can help. -1 minus -4. -1 plus 4 is? So then I have y3 placeholder 1 like this. Also, look at what I did with brackets. Like it's the top exponent to take away the bottom exponent. But those exponents are negatives themselves. So if I could just stay so organized, then I'm good. And I can type in -1, take away -4, like that with my brackets into my calculator and be safe. right? Maybe your fraction, or pardon me, maybe your integer operations are no good. Then just know who you are, be aware of that, and use your calculator properly. Use brackets, right? All right, let's finish this guy off. Simplifying the inside, I have xy cubed over 4 squared. Now I got to go power of power. And what do I get? X squared y to the 6 over 16. This is your final answer. Because that whole thing has to be squared, right? So what's x times x? X squared. What's y cubed times y cubed? Y to the 6. And what's 4 times 4? 16. So, easier said than done, especially if I'm doing it at the front. These ones, you're gonna have to practice for hours to get good at these. Okay, the start of the workbook today, like you could probably sleep on that one and be fine, but these ones, like you gotta practice. Like look at this nastiness. Yeah, that's like just gross, right? So the first thing I want you to gaze upon is that this minus 3 power, go for it. Thanks. This minus 3 power is for this bracket only. Do you guys notice that? It's not on the 10. Okay, so I'm going to apply the power of a power on the numerator. This will be p to the minus 9. What am I doing? Q to the minus 6, r to the 0. What did I do? What did I do with those powers? Multiplied. That's power of a power. Okay? They're already powers, and then you're going to raise them to another power. You have to multiply. So same thing happened on the bottom. But like this negative 3 didn't affect the 10, but this negative 2 does affect the 8. You see that? All right, so we got 8 to the minus 2, p to the positive 6, q to the negative 10, and r to the negative 6. All I'm doing is multiplying. Whoa. Okay. And the first step? The first step, we're just doing power of a power. Now, in this second step, you have to think the p's go together, the q's go together, and the r's go together. And the coefficients go together, right? As well as these coefficients go together. Like that coefficient doesn't scare me, because I got this fancy guy. What was it? 10 divides what? 8 to the minus 2? 640? How did I guess 640 before I came up? What's 8 to the minus 2 in the top? What would 8 to the minus 2 be in the numerator? If I move this guy up to the top, what would it be? 8 squared, right? Because if you move something from the denominator to the numerator, you have to switch the sign on the power, right? What's 8 squared? 64. 64 times 10? 640. So you know it's going to be 640 over 1, placeholder. Now into the pink. And again, like, oh my gosh, this is just frightening. Follow the rule. 6, whoops, backwards. -9, take away 6. That's p to the minus 15. Do you agree? Next one, q. Do you know what we're doing here? Subtracting powers? Yeah. This one would be -6, take away -10. Q to the 4. And then the last one would be 0, take away -6. What would that be? Just 6. Now we need to think about this. All this stuff was like in a bubble on the side. Let's think about the purple. Do you see how you have 6 in the bottom already? Just do the P in the purple on the bottom. See how there's 6 of them? Where do these 9 have to go if it's negative? Negative power means I need to put it to the bottom. What's 9 and 6 make? 15. 15 in the bottom, just like my rule says. See my rule? P to the minus 15. I need 15 in the bottom for P. Keep going. What about the Q's? It's -15 if it's in the top, +15 if it's in the bottom. Good question. Now look at this one, q to the 4. Why is it q to the 4? If I took those -10s and put them to the top, it would be +10, right? You had 10 q's, take away 6 q's, 4 q's. And now the last one. It is very confusing, but you have to think, how many factors do I have? What does this r to the -6 tell you? It tells you there's 6 r's, but they need to be flipped. So 6 r's need to go to the top. The 0 tells you there's no r's up there. So those 6 r's go to the top, and that's exactly what you're left with. Okay, so the proper way of writing this would be 640 q to the 4 r to the 6 over p to the 15. And then you're like, oh yeah. Pretty nasty, right? We are going to spend a whole nother day on this, so don't freak out. So like these ones we'll leave for tomorrow, so you guys can get started on this. This assignment on the bottom, you have it in your book? Right, that assignment, you have it in your book? So then I'll just leave these notes up just in case you still want them.